All right, this is a quick video. Normally we would go over this and it would be, stuff that we learned, but since we're short on time, I'm going to count just this as extra credit. I hope you watch the video because it is something that we should have been able to get through and go over. And it's the laws of sine and cosine. They're also called the sine rule or the cosine rule. And what's good about the law of sines and cosine is that everything that we've done up to this point, as far as trig and all the other stuff in this chapter goes, has had to have a right angle in the triangle. And that's the only way it worked. Law of sines and law of cosines works for any triangle. So it doesn't necessarily have to have a right angle in it. It could have a right angle, but it doesn't have to. It works for all triangles. Law of sines, cosines, sort of difficult, but it's not really all that hard. The first thing that you have to be able to decide with law of sines and cosines when you're looking at a problem is which one to use. And there's 4 things. 2 for law of sines, 2 for law of cosines. It's going to help you decide which one am I using. When it's the law of sines, or when to use the law of sines, is if you know this information. 2 sides and an angle opposite one of those sides. So we know 2 sides, and we know the angle across from one of those sides. Then we're going to use the law of sines. If we know, and I'm going to mark this out, if we know 2 angles, and I got this in here wrong, it should say any side, doesn't have to be across from one of them. We know 2 angles in any side, then we're using the law of sines. Now the reason it's any side is because if I know these 2 angles and I add them up, I can subtract that from 180 and I can find the 3rd angle down here, and then I have a side and an angle that match up. So to use the law of sines, the main thing is that you have a side and an angle that are opposite of each other. That's to use the law of sines. The law of sines is this proportion here, and we're going to talk about when you label a triangle, or how to label a triangle and stuff. We're going to come back to this slide here in a second. The law of cosines is this big long formula. A lot of people like the law of sines better because the law of cosines looks so difficult. A lot of times the law of cosines is really easy because your calculator is going to do all the work for you. And we'll talk about the law of cosines here in a minute. The ends of the formula, we'll talk about it here in a minute. What I want to talk about next is when to use the law of cosines. So these are 2 things that tell you when to use the law of cosines. If you know all 3 sides. So if you know all 3 sides of the triangle, and apparently you're trying to find one of the angles because those are the parts you don't know, then you must use the law of cosines. If you know 2 sides and the included angle, when we did stuff like side angle side, if you remember back to then, that angle in the middle had to be the included angle. And all that means, a lot of students had trouble with this, all that means is if this is one of our sides, this is one of our sides, it has to be the angle where those 2 sides come together. That's the included angle. So if we know this information, 2 sides and the angle that's between them, or if we know 3 sides, then we use the law of cosines. If you know an angle and a side across from that angle, then that tells you using the law of sines. So you're going to set up each equation according to which one you need to use, whether it's law of sines, law of cosines. Now let's go back on the law of sines. Law of sines looks like this, and it's always just setting up sine of an angle over the side across from that angle. So sine of angle A over little a equals sine of angle B over little b. Whenever we're doing this, we only need 2 of these parts. We don't need all 3 because we're setting up a proportion. So we're just setting up 2 of them. Remember, when you're labeling a triangle, if I give you a triangle, and let's say it's triangle NTH. So if we're using that triangle, the side across from big T is always going to get labeled little t. The side across from big N is going to get labeled little n. The side across from big H is going to get labeled little h. So the little letters are the sides, the big letters are the angles. And we use that a lot in law of sines, law of cosines. We got to make sure that everybody's on the same page as far as what their triangle is labeled. Again, we're only going to set up 2 of these. So if I was using this triangle, my NTH triangle here, I might set up something like sine. Sine's always going to be on top of maybe angle T over little t equals sine of big N, angle N, over little n. If that's what we want to set up, you can set up any of those together. So we could use these 2 together. We could use these 2 together. We could use A and C together, just so that you have 4 parts here. So you have a proportion. And then all we're going to do is we're going to cross multiply and solve that. That's what makes sine a little easier than cosine. We're going to do 2 examples of each of these, of the law of sines, law of cosines, here in just a minute. Law of cosines looks like this. With the law of cosines, first thing I'm going to say is, if we had a different triangle, like triangle NTH, these letters really don't mean a whole lot. A, B, C, they're just variables. If we had, it could be triangle NTH, could be triangle QRP, whatever the triangle is. When we label this triangle, this is going to be little t, this is going to be little n, that's going to be little h, across from the big letters. And let's say we're looking for little h. Then when we go to set it up, we want little h to be here. So this one or this one always has to be our variable. This one's going to be our variable if we're looking for a side. This one's going to be our variable if we're looking for an angle. But the variable always has to be on the ends. Otherwise, everything else, all this stuff in the middle here, it's always going to be numbers. So that's what's going to make this formula not so difficult, because we're going to just know the numbers and we're going to stick them in here and let our calculator do the work on most of it. So there's only going to be one variable in here. It's either always going to be right here if we're looking for a side, or right here if we're looking for an angle. So if I'm doing NTH and I'm looking for little h, the length of that side, then little h goes on the far left. And then all the other letters in here, the B, C's, notice that these 2 letters are the exact same as these 2. It's always going to be that way. And it's going to be the other 2 sides. So I might do n squared plus t squared minus 2 times n times t, then times the cosine. If this is little h over here, it has to be big H on this other end. So it'll be the cosine of that angle. These 2 letters, always going to be the same letter, one small, one big. And then these letters in the middle here, these and those are always going to be the same. And if we're looking for little h, then we know a number for n, we know a number for t, we know a number for n, number for t, and a number for big H. And we're just going to plug all that in and do the math. Once you find one part using the law of cosines, because it's usually a little more difficult, or most students find it a little more difficult, which it's not really. Once I do a couple, you'll see. then you might want to, if you're looking for other parts in that triangle, you might want to go back and use the law of sines to find those other parts. All right, we're going to do 4 examples here. The first 2 will be using the law of sines. Next 2, the last 2 will be using law of cosines. This first one is finding a side using the law of sines. Then we'll do one finding an angle. And this says on a worksheet. This isn't on a worksheet. This is just this PowerPoint. First thing you need to do is label your triangle. We got the angles labeled already. We know that little c is across from big C, so that's going to be over here. So I'm going to label that 12. That was little c. Angle A is 80 degrees, so I'm going to put that in there for angle A. Angle C is 40 degrees, so I write that in there for angle C. And we're looking for little a, which is going to be across from big A. So this over here is going to be little a. And we know we're using the law of sines because we have this 40 and this 12 that are across from each other, so they match up. So we're using the law of sines. And all it's going to be is setting up a proportion. And I'm actually going to do this 2 different ways. You pick whichever way you like the best to do it. That's up to you. It's always going to go sine, sine. It's always going to be sine on top of both parts. And we pick our angle. I usually pick the ones that I know the angle and the side that match up first. So sine of our angle, which is 40, and that goes over top of 12. Then on the other one, sine of 80, and that goes over top of A. And again, we could look at this. We know that 40 plus 80 is 120. Subtract that from 180. We know angle B up here is 60 degrees. Doesn't really help us with anything, but we can find that other part if for some reason we needed to. Now, the first way I'm going to do this is I'm not going to grab my calculator right away. I'm just going to leave the word sine in there as I do all the math. And this confuses some students, so I'll do it the other way after that. So all I'm going to do is cross multiply. When I cross multiply going this way, the way I want to write this is I want to write the A out in front times the sine of 40 equals, then when I cross multiply this way, I want to put the number out in front, so 12 times the sine of 80. Now I put them out front, this 12 and this A, because if you put it on the other side, it ends up confusing you. So put them out front to make it easier on yourself. We're trying to solve for A, so all we're going to do here is divide both sides by the sine of 40. And again, I know it may be confusing this way to some of you, so if you don't like it this way, do it the other way that I'm going to show you here in a minute. These cancel out, and we end up with just A on this side. Then I grab my calculator, and all I'm going to do is I'm going to punch in this top part, 12 times sine of 80. Punch it in just like that, then I hit equals, and it gives me that number. And I'm not going to write that number down or anything. I'm just going to leave it right there on my calculator. And then what we want to do is we want to divide by the sine of 40. So then I'm just going to hit divided by sine of 40, and it's going to tell me the answer. And I'm going to round that off to about 18.4. So that side A is about 18.4 units long, whatever the units are. And again, notice this wasn't a right triangle, so we can solve or find the parts of any triangle using these laws. The other way that I could do it, if that way confuses you, leaving the words in there, the sign word in there confuses you, then the other way you could do it is we still set it up the same. Sine of 40 over 12 equals the sine of 80 over little a. And then what I do is I grab my calculator and I get rid of that sine of 40. So I punch in sine 40 and it gives me 0.6428. That's over 12 equals, then I do sine 80, and that's 0.9848, and that's over little a. So now I don't have the words in there anymore, and now I cross multiply. When I cross multiply this way, I get 0.6428 times a. And when I cross multiply this way, I can grab my calculator again, and I can do 12 times 0.9848. And I get 11.8176. You've already got that number on your calculator. The next thing you're going to do is you're going to divide. You're trying to get a by itself, so you're going to divide both sides by 0.6428. That number right there is already on your calculator, so you can just hit divided by 0.642, oops, not 6, 28, and it gives me 18.38, which we're going to round off to 18.4. So it gives us the same answer either way. So if you would rather do it this way and not write down all those decimals all the way through there, that's fine. And if you don't like the word sign in there and you want the decimals because it looks more sensible to you, then do it this way. Either way, it makes no difference. They both give you the same answer. All right, so that's the setup for finding a side if you're using the law of sines. Now we'll find an angle using the law of sines. Same idea. Let's label our triangle. Little b is across from big B, so that's going to be down here. That's 20. Little c is across from big C. That's going to be over here, so that's 26. Angle C is 52 degrees. Put it in there. We're looking for angle B, so I'm just going to mark it so I know that that's what I'm trying to find. We're using law of sines because we have a side and an angle that are across from each other. So when I set up my proportion over here, first thing I'm going to do is sine. Well, the sine of our first angle is 52, and that matches up with the 26. Our second angle we don't know, so I'm just going to put B in there in its place, and it matches up to the 20. So I set up that proportion. I like doing it with the words in there, so that's the way I'm going to do this one. I might go through and do it the other way also, just to show you. Here we're going to cross multiply. When we multiply this way, we get 20 times the sine of 52 equals, this way we cross multiply, and we've got 26 times the sine of angle B. Next thing I'm going to do, I'm trying to get sine of angle B by itself. Since you're looking for an angle, this one's going to take a step longer than the other one. But here I'm going to divide both sides by 26 because I'm trying to get that part by itself. Divide the other side by 26. These cancel out and you're left with sine of B equals, and I'm just going to stick all of this right here into my calculator. 20 times sine of 52, close the parenthesis there, hit equals. So that's what's on top. Then I just hit divided by the 26, and I end up with 0.6062. That's not our answer because we're looking for the angle. That's what the sine of angle B equals. So if you remember when we were doing this, when we were looking for an angle on your calculator, you have to hit the second or the shift button, depending on which kind of calculator you have. So on my calculator, I'm just going to hit second sine. Notice it pulls up at sine -1. Tells the calculator we're looking for the angle. And then I just punch in this number right here, 0.6062. And it tells me the angle. So 37.3. We're going to round that off, so the measure of angle B is just about 37 degrees. So if we look back here, angle B right here is 37 degrees. We could then add those two up and find angle A if we wanted to. Then we could set up another proportion and find little a over here if we needed to. But for this, that's all we were looking for was that. If I do it the other way, sine 52 over 26 equals sine of b over 20. If I just grab my calculator and I do sine, let's clear some of this. Sine 52 gives me 0.7880 over 26 equals sine b over 20. I cross multiply, I get 26 times the sine of b. You'll probably notice that it's coming out the same as what it did on the other side, just a little different setup. And then going this way, I take 20 times 0.7880 and I get 15.76. Then I'm going to divide both sides by 26. These cancel out. You're left with sine of b on this side. 15. I already had it on there. I don't know why I did that. Let's say divided by. Nope, it won't do it. Divided by. So now it's just going to divide that answer by 26. I get 0.6062. Then I'm going to take that number and I'm going to hit second sine 0.6062. Notice again, it tells the calculator we're looking for an angle, and we end up with 37.3, which is about 37 degrees. Same thing we got the other way. So that's using law of sines. Using law of cosines, if we're trying to find a side, it's really easy. So if we're trying to find a side using law of cosines, we label the triangle, write out the formula with the side finding, the side that we're trying to find. My English there is not very good. Is on the far left. So when we do the formula, it's going to be on that side, the equal sign all by itself. Plug in everything else. We're going to know numbers. When this says plug in everything on the right, we're going to know numbers for all that. Plug it into your calculator. It's going to give you an answer. Then you just take the square root of that answer, and it's going to, that will be your answer. That'll be the length of your side. So we'll do one of these. If I label my triangle, I'm just going to label it triangle ABC. Notice that my triangle just looks equilateral. Doesn't matter what the triangle looks like. You got ABC. We know little b, which is across from big B, is 14. So I'm going to put 14 right there. Little c is 12. Angle A is 62 degrees. We're trying to find little a, which would be across over here. That'd be that side right there. So now notice that we can't use the law of sines because the two sides that we know aren't across from that angle, and we don't know either of the two angles that are across from those sides. So we have to use the law of cosines. And again, the law of cosines, it looks like a squared equals so and so on. It's that big long formula, but you got to set it up the way that you want it. It doesn't matter if you have a squared on the left or q squared on the left. If that's what you're looking for, that's what you want on that side. So this time it happens to be that we're looking for little a. So that's what's going to be on the left. And I'm just going to write the formula out here. And again, it doesn't always have to be, it's a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. These letters, A, B, and C, are arbitrary. They don't, it could be any letters in there. All right, but this letter, this little a, is always going to have a big A on the other end, and the B and C here are always going to be the same as the 2 here. So that's my formula. This time I happen to be looking for little a. Probably shouldn't have set it up. I should have found some other side or something, or something different. But I'm looking for little a, so it's going to be little a squared on that side all by itself. Then I want little b next, and I'm going to label this. This is little b, this is little c. just so I remember. So little b is 14 squared plus little c squared, which is 12, minus 2 times little b, which was 14, and little c, which was 12, and then the cosine of our angle A, which we know is 62. So when you plug all that into the formula, you notice if you're looking for a side, you know everything. All this is numbers now. And you don't, it's not hard because your calculator is going to do all the work for you. So all I'm going to do is I'm going to take my calculator and I'm going to plug this in just like it looks right here. 14 squared plus 12 squared minus 2 parenthesis 14, close the parenthesis, open another parenthesis, 12, close the parenthesis, new parenthesis, cosine 62. Now the bad thing here is that my calculator puts in an extra parenthesis right there, so I actually have to close 2 parentheses because I have to close this one that I put in and I have to close that one that they put in. Then I hit equals and it gives me this number. So a squared equals 182.2575549. A whole bunch of you probably know how to use your calculators a little better than I do, and you could have probably went ahead and did this last step as part of that. And if you can, that's fine. Just make sure it's giving you the right answer. The last thing that you want to do when you're finding the side, we don't want, this is a squared. We don't want a squared, so we got to take the square root of both sides. So we're taking the square root of a squared. That's just going to leave us with a. And we're taking the square root of this number. So I'm going to hit second square root 182.25. And you probably don't have to stick in all of these numbers. I'm going to stick them all in there since I already have them. Hit equals, and it gives me about 13.5. So the length of this side right here is about 13.5. You can check to make sure that your answer sort of makes sense. Remember, we had some rules where 2 sides must add up to be more than the third side. So as long as that works, it's probably a sensible answer. That's how you find a side if you're using the law of cosines. Again, you're going to plug into this formula. The side you're looking for has to be over here on the left, all by itself. You're never ever going to have a variable in here anywhere. Your variable is always going to either be here or there. If you're looking for a side, it's going to be there. On the next one, we're looking for an angle, so our variable is going to be down here, and that's a little more difficult. If we're looking for an angle, this is what you're going to do, and you're going to have to do this in steps. You label the triangle, write out the formula with the angle on the far right. So it'll be like big A or big B on the far right. Whichever setup it is. Sorry, my PowerPoint confused me. On this number 3, it should say you're going to find a squared. So you're going to find this part, write it down. Then you're going to find b squared plus c squared. So you're just going to punch this into your calculator, write that answer down. Then you're going to find the third thing you're going to find is this part. 2 times b times c, and you're going to write that part down. Sorry, my PowerPoint was color-coded, but then when I ran off the slides, so this was each of these were a different color. So we're going to find this, write that answer down, this, write that answer down, this, write that answer down. I'll show you when I do an example. When you get finished with all that, it's going to look like this. So it's going to have a number here, minus number here, times the cosine of A, because that's what we're trying to find. We're trying to find angle A. Then you got to do three things. You're going to subtract this number on both sides. So you subtract it on both sides of the equal sign. Then you divide both sides by whatever this number is. And don't forget, if it's a minus there, that means it's a negative. So you divide both sides by that. And then you end up with something that looks like this. Cosine of A equals this. Well, then we're going to hit second or shift on your calculator. And it's going to look like this. Cosine -1. Then you just punch in that 0.6420 into your calculator, hit equals, and it's going to tell you the angle measure. Hopefully it'll make more sense as I do one of these examples. So first thing we're going to do, we're going to label our triangle. I'm just going to put A, B, and C since I didn't already have it. Looks like we're using A, B, and C. Little a, that's across from big A, is 11. Little b is 10. It's across from big B. Little c is 12. And we're trying to find angle B. So this is the angle we're trying to find. No, it's not a right angle. It's just that's the triangle that I happen to draw there. I mean, it could be a right angle, but we don't know that for sure. So when we set up our equation, way out here on the right, it's going to say cosine of big B. And that means little b has to be over here. Well, we know little b, and I'll put them in here. That's little b, that's little a, that's little c. We know little b is 10, so it has to go over here on this side. Little b on this side, big B on this end. Then our other letters are A and C, and we're just going to put them in here. A squared plus C squared minus 2 times A. Same, these two numbers right here go right here also. And then, so if that was 11, that came first, and you put the 12 right here. That's your setup for your equation. Then we just do little parts. So we do this part, 10 squared. I grab my calculator if you need to, and you just do 10 squared, and you write down that answer. So that's 100. So, and then we do this part. So we do this part first, write it down. Then we do this part second, and I'm just going to plug it all in my calculator just like it looks there. 11 squared plus 12 squared, and I write that answer down. Then I do this part. It's going to be minus, unless one of these happens to somehow be a negative, which it probably won't be. So it's going to be minus there. 2 times 11 times 12. So 2 times 11 times 12. And I write down that answer. And it's still times the cosine of B out here hasn't changed yet. So now my equation looks like this. 100 equals 265 minus 264 times cosine of B. Where a lot of students run into a mistake here is the next thing they do is they subtract 265 minus 264. Your PEMDAS, your order of operations, that doesn't work. You cannot do that. I know it looks easy, but you can't do it. What you got to do next is you take this number, whatever it is, and you subtract it on both sides. You got to solve it like you're solving, like this here is just a variable. So you have an equation that looks like this. 100 equals 265 minus 264 times x. It's like you're solving that equation. You're trying to get that x by itself. So you got to subtract this first. Minus 265. That ends up giving us negative 165 equals, these two cancel out. Over here you're left with negative 264 times the cosine of B. The next step, we're trying to get cosine of B by itself, so we want to divide both sides by whatever's out in front of it here. got to remember that you're dividing by a negative here. So it's going to be negative 264. If we do it on that side, we got to do it on this side. These two cancel out. You're left with just cosine of b on the right. On the other side, we grab our calculator, and I do negative 165 divided by negative 264, hit equals, and I come up with 0.625. So now I'm looking for an angle. This is where on your calculator you got to hit second or shift. Since you're looking for an angle, so you're just going to hit, I'm going to clear this off, I'm going to hit second. I want the cosine this time. Remember, it comes up cosine -1. That tells the calculator you're looking for an angle. Then you put in 0.625. Close the parenthesis, hit equals, and it tells you the angle. And we're going to round it off. So the measure of angle B is about 51 degrees. We'll round it off to the nearest degree. So again, on the thing, you got to know if you're using the law of sines or if you're using the law of cosines. And the way you can tell, law of sines, if you have a side and an angle that match up, you're probably using the law of sines. If you have, even if you don't have that, if you have two angles and any side, then you can find the third angle and match it up with a side. So if if a side and an angle are opposite each other, law of sines. If you know three sides or two angles and two sides and the angle that's in between them, then you're using the law of cosines. I'll probably put another video out that will do a couple, 2 or 3 of the problems off of the worksheet. Again, the worksheet's extra credit, so hopefully you watch the video just to get a little idea, but if you do the worksheet, it'll be extra credit.